There's a lot to be said about the quadratic formula and about graphing quadratics and whatnot, but today I want to focus on a topic that a lot of times students overlook, and that's the discriminant. Now, what I have originally written up here is the quadratic formula. X is negative b plus or minus the square root of b squared minus 4ac over 2a. This part under our radical, this b squared minus 4ac, that has a specific name, and that is known as our discriminant. And I want to talk about how that affects us when we solve quadratic equations and how it affects us when we graph quadratic equations. When we look at the discriminant, all we really care about is one thing. We want to know whether it's positive, negative, or 0. If we were to simply plug in numbers for b squared minus 4ac and it turned out to be greater than 0, then what that tells us is that if we were to solve that equation, there would be two real solutions. Similarly, if we were to plug in b squared minus 4ac and we got it equal to 0, that would tell us there's one real solution. And finally, if b squared minus 4ac was less than 0, that would tell us there's no real solutions. Which makes sense, because if b squared minus 4ac, if our discriminant is less than 0, that means we have a negative underneath our radical. And when we're dealing with negatives under radicals, those are imaginary numbers, which are not real numbers. Now, what is this really telling us? Well, we think about it in terms of graphing. We look at our table down here. We have three situations. You'll notice these parabolas. In my first parabola, it intersects the x-axis twice. My second parabola intersects the x-axis once. And my third parabola does not intersect the x-axis at all. Well, this corresponds to my discriminant. In this first example, where it intersects the x-axis twice, this is one example of a discriminant which is greater than 0. This tells me there's two real solutions, or two x-intercepts, and I should know automatically when I'm solving a quadratic equation by using the quadratic formula, I should be able to identify that there are going to be two x-intercepts just by seeing that my discriminant is greater than 0. In this case, where it only touches once, this is a great example of where my discriminant is equal to 0. There is one solution. When you think about it, if we go back to our quadratic formula up here, if b squared minus 4ac is equal to 0, the square root of 0 is 0. So adding 0 and subtracting 0 are basically the same thing. So this whole piece of the quadratic equation basically disappears, and I simply get negative b over 2a, which is a single solution because I eliminate the plus or minus part in the numerator when it equals 0. And finally, my last example over here is when b squared minus 4ac is less than 0. That means that I get an imaginary number underneath my radical. And you can't really graph imaginary numbers, not in the xy plane, like we know. Again, all of this can be determined using your quadratic formula. Again, there are other ways of solving quadratic equations. You reviewed those as well. There is the factoring, there's the square root method, there's completing the squares. All of those are effective. But the quadratic formula adds that extra little bit by giving us the discriminant, which is built into it. Let's see how this works. We have an example here, x squared minus 4x plus 5. I simply want to know how many x-intercepts I have. I plug in my discriminant, b squared minus 4ac. This is negative 4 quantity squared minus 4 times 1 times 5, which is 16 minus 20, which is negative 4. I know automatically, because my discriminant is less than 0, that it's not going to cross the x-axis. There are no x-intercepts. And if we graph this using a graphing utility, we'll notice that's exactly what happens. And that follows the rules we already know. We know from this x squared minus 4x plus 5 that we get a leading coefficient of 1, and if the leading coefficient is positive, that means the parabola faces upwards. And from our discriminant, it tells us it doesn't cross the x-axis. And that is exactly what we wound up with here. And we also notice that the y-intercept is a positive 5. So positive 5, facing upward, no x-intercepts. That's the exact graph we got just by checking our discriminant. Our next quadratic function, let's look at f of x equals x squared minus 4x minus 5. Now this looks almost just like what we just did. Please notice the only thing we did was we changed the c term from a plus 5 to a minus 5. We're going to do the same thing. We are going to get b squared minus 4ac. We get negative 4 quantity squared minus 4 times 1 times negative 5. This simply becomes 16 plus 20, which is 36. Now, our discriminant is positive, so we know there's two x-intercepts. We go back up to our graph. Leading coefficient is 1. It's positive, so it faces upwards. And the y-intercept is negative 5. So here, we sketch the graph. We have it faces upwards, two x-intercepts, y-intercept of negative 5, and we could actually calculate these x-intercepts by completing the actual quadratic formula and finding out what they were. But the general idea of the discriminant is to give us an idea of what types of solutions we're dealing with and how many x-intercepts we're looking at.